Good day everyone. I'm here to talk about a new Eclipse Foundation project focused on reducing the fragmentation in the consumer and IoT product industry. Our ultimate goal is to raise the bar for creating great IoT products. Before we begin, a little bit about myself. My name is Amit Kucheria and here's a picture of me. Oh, I need to fix that. How about that? Hi there. I am the Chief Product Architect for Oniro. I am also a Linux and Zephyr developer, and over the years I've worked on multiple products, distributions, with OS vendors and SoC vendors. Let's begin with the problem statement, the Internet of Things. There are hundreds of companies across the world, small and big, building thousands of devices that fall into the broad category of Internet of Things. These devices or products run a variety of open source operating systems like Linux or an RTOS such as Zephyr, FreeRTOS, etc. But they suffer from some common problems. Internet of Things can also be called Internet of Abandonware because in a lot of cases the companies no longer support the product after releasing it to the market with software updates or bug fixes. These devices very often suffer from silos due to their dependence on cloud connectivity for the most basic day-to-day functions, as well as the inability to be mix and matched with similar devices from other vendors in the local network. Very often, these devices lack the most basic security features such as a trusted boot chain, encrypted network communications, encrypted local storage. They may also have unused network services running all the time, thereby exposing the device to network-based attacks. They may also suffer from a terrible onboarding experience, sometimes requiring you to download an application from the App Store just to configure the most basic of functionality. So you end up with an application for every product or device that you have in your home. Surely we can do better than that. Let's consider the path to building a product using open source software. You need to start with a shopping list. You start with your hardware. So you have to decide whether this is something that will run on a microcontroller or a CPU. If it's a microcontroller, you would go for some real-time operating system like Zephyr, FreeRTOS, etc. If it is running on a CPU, you would probably go with something based on Linux. Now, depending on your use case, you'll have to put together a list of software components that are required to satisfy that use case. So for example, if you're building a smart speaker, you obviously need to put together a list of components required to record and play back audio. So far so good. Now you need to integrate all of these software components into an image build that when flashed onto your target hardware device will produce the behavior that you want from the product. In order to integrate all of this software in a deterministic, repeatable manner, you might choose to use a project such as Yocto or Buildroot, which act as repositories of recipes for tens of thousands of different software components. So what they make it very easy to do is to pick a bunch of software components and build them into an image that you can use. They're also very flexible in that they allow you to tweak the configuration of these components. But this flexibility comes at a price. Very often, the recipes will not build the software with the exact options or features that you want for your product. So you end up having to customize this. So now you have a bunch of recipes and you need to comb through them and tweak them to build the various software components just right for your product needs. This is actually a lot of effort. So now let us look at where some of the engineering effort into building a product goes. The effort required in building a product software stack can roughly be categorized into 4 parts. So the first part is where you build the core software stack on top of which you will develop your application. So this includes the kernel, the tool chain, the various low-level libraries, the application frameworks that you might use to build your applications on. Once the core software components are chosen, the engineering team typically shifts their focus onto setting up processes to enable rapid development. So they set up CI/CD infrastructure, testing infrastructure, write documentation, and set up maintenance processes. This effectively allows them to catch regressions very quickly during the development process. And if the engineering team really cares about the quality of software they put out, they probably even have security policies. For example, the root of trust, starting at the factory floor, signed images, key rotation policies, providing over-the-air updates for software, and even an IP compliance policy. Another thing the engineering team ends up spending time on is configuration for their products. This could be, for example, if you have multiple variants or SKUs of a product and each of them have a different configuration that needs to be maintained separately. It could be related to your product specific policies, so that you disable default usernames and passwords, prompt the user for a stronger unique password, prompt them to set up secure SSH, maybe disable unnecessary services so as to reduce the number of ports that are open to the network. All of this kind of policy and configuration needs to be saved separate from the core software because this could be very specific to your product. And finally, you have your application. In a lot of cases, your own application code and business logic could be as little as 5 or 10% of the overall code that is shipped onto a product in terms of lines of code as well as effort. Many of the areas such as OTA, security, and IP compliance require experts that might not be available to all companies. It is also work that is being repeated across the hundreds of companies building IoT devices, when you could actually share some of this work and focus on your own applications. This is what we are proposing with Oniro. I invite you to join the Eclipse Oniro project to help build an open source, hardened IoT software stack. By using shared engineering, we would like to raise the bar for IoT software security. By using opinionated defaults, we would like to deliver key features such as over-the-air updates, SBOM generation, and hardened network defaults out of the box for every user of Oniro. This in turn will allow engineering teams to spend more time on their applications and their value additions instead of the same thing being repeated across many companies. And we would like to offer these features for devices running CPUs as well as microcontrollers, so that Linux is supported as well as a couple of carefully chosen real-time operating systems. Coming back to the premise of this talk, focus on your applications again. Here is how we have built Oniro so far. We have started with Yocto with its native Linux support and improved the support to build Zephyr applications inside it. This allows for a unified developer experience regardless of whether you're building a product for a CPU or a microcontroller market. For example, we've gone ahead and ensured that obsolete ciphers are no longer used with the versions of SSL that ship with Oniro. We have plans to do the same for the kernels in terms of hardening features as well as tool chains. We are starting to add support for common security policies so that things like trusted boot, CVE checks, support and update policies, key provisioning are part of the Oniro core stack. On the OTA front, our OTA engine will be able to deal with OS-specific flash partition layouts and also with the OS-specific software. So in the case of Linux, it could be Rauk or OS Tree or Tough, whereas on Zephyr, it could be something like DFU and MCU Manager. On the network side, we already have support for OpenThread, Wi-Fi, and BLE. We plan to add Project Matter support. And on the application protocol support, we already support WebSockets, MQTT, and CoAP. More support for newer network protocols will be added as and when necessary. As mentioned earlier, all of these protocols will default to secure communications. As seen at the top of the diagram, there will also be an application UI framework to allow writing of portable applications across Oniro and the OpenHarmony ecosystems. There will be a agent framework that allows for discovery of devices within this ecosystem and allow context-aware reconfiguration of those devices. In a nutshell, Oniro will offer opinionated defaults for a variety of things that engineering teams currently have to spend a lot of effort trying to nail down. Things like what is the choice of libc, what are the kernel configurations I need to use, what are some of the security policies that would be applied to a product. But why stop there? We are using Oniro to build minimum viable products for a variety of real-world use cases. For example, a smart door lock, a smart light, or an IoT gateway. We call them blueprints. What blueprints allow us to do is improve our integration testing, and they are a vehicle to attract more OEMs to the project. We intend to use blueprints to show what is the state of the art in the area of security, network communications, OTA, IP compliance, etc. All of these blueprints will be reproducible on community hardware like Raspberry Pi or Arduino Nano BLE, and they will be improved over time so that the same blueprint gains more features as we keep working on them. We've also been working with some very smart lawyers who are open source friendly to help us build a SBOM dashboard to give us a better insight into the licenses that we use while building our software images. This will be provided as part of the project so that anybody using Oniro to build their product would automatically get an SBOM license as an output of the images that they create. Oniro will comply with industry standards for code, processes, and security. Through the Open Atom Foundation, Oniro will be compatible with OpenHarmony. This will provide a very broad market for anybody developing applications and devices on top of Oniro. It is now time to summarize my talk. So Oniro is an Eclipse Foundation project. It is an OpenHarmony compatible operating system designed to reduce effort and fragmentation in the IoT industry and to raise the bar to creating great products. With the use of blueprints, we want to reduce the effort in getting started with the platform on low-cost commodity hardware, and in general, we want to raise the bar for security, OTA, and networking technology in the area of IoT products with this platform. With that, I have come to the end of my talk. Thank you very much for listening. Please visit us at oniroproject.org for a pointer to our mailing lists and our source code. And if you have any questions, I am happy to answer those.
Hey everyone, I'm guessing I'm live right now. Indeed. Okay, I'm going to try to address the questions that have been asked so far. I'll go in the order they were asked. Okay, so the first question was, what is used as the application framework? Is it leveraging Flatpak, Snaps, or something else? Great question. So at this point, we haven't made up our minds on what the application framework will be. So as I announced, this is a recently formed Eclipse project. We have currently used native um, native applications for some of our demos. We've also used LVGL for our UI at this point, but we have a bunch of partners in the project, and we are currently going through what the requirements are for choice of application framework. A lot of people have investment into Android apps. People have investments into JavaScript-based apps. And we are currently trying to figure out what would make most sense for the current set of partners that we have in the Eclipse working group to use as the application framework. We do have plans for containerization of these apps. This is currently being planned. This is currently planned activity for this year, so that the next release of Oniro, which will be end of this year, will support containerized apps so far. So if you are interested with your input, we invite you to engage with us on IRC or Mattermost. Come find us and talk to us about the application framework. The next question from Alexander, what are you doing on middleware in Oniro for Linux? So middleware is a fairly broad subject here. I'm guessing you are talking about OTA and security, Alexander, over here. Perhaps you can mention this in chat. But anyways, I mean, assuming that's what you were referring to. So since we start with the stock Yocto, and then we've added some opinionated defaults on top of that. So that's what our stack is for Linux. And then we are building an OTA solution on top of that, along with a associated cloud component. We also have Marta, who is also attending FOSDEM, working to harden a lot of our core software stack. So effectively, we are literally going through various Yocto recipes and the components that we've chosen for some of the blueprints, and figuring out, okay, what at each level. So right, starting from the kernel, the tool chain, what flags need to be enabled by default for Oniro, and same for libc, and then going further up the stack as we go. Same thing for network protocols. So if you're going to use, let's say, MQTT libraries or CoAP libraries or Project Matter or Open Thread support. So ensuring that TLS is used by default if an application is written on top of Oniro, so that so our SSL libraries are able to build against any network application that you might create. So these are some of the things that we are putting into place at this point. So the next question again from Alexander, what OTA protocol tech we are using? So the tech we are currently using is based on Rauk. We have Ziga in the Zygmunt in the channel as well. So he's driving that effort, and the idea is that there is a sys for TA, so there's an abstraction on top of that, which is Oniro specific, but open source, that will be able to drive RAUC. So we leave the actual handling of the update and flashing it onto the board to RAUC, but fetching it from the network and all of that all will be handled by sys or TA. And eventually we will roll this out to Zephyr as well. Another question from Alexander. How will I, as a product maker, be able to consume Oniro? Will there be binary outputs and packages like containers, or is it all Yocto layers? Good question. So far, what we've done is we have some reference hardware platforms. It is a mix of community hardware that's commonly available. So we support the Raspberry Pi 4 for Linux and the Arduino Nano BLE running Zephyr. And then we have some partner platforms. So one of our partners is Seco, and they have a couple of very interesting platforms based on x86 and the IMX8 that we are using. So it's the B68 board and the C61 board from Seco. And we build all of our software and test it on these platforms. Whether or not we will make binary images available for consumption is something we haven't answered so far. If there is interest in that, I think that can be arranged. We have to figure out if there is any IP restrictions to doing that. But other than that, you will definitely have access to all the Yocto layers and the instructions in our documentation to build anything that you might add there. Let me go back to chat to see if there's any other questions. Okay, so Alexander replied with he's also interested in knowing about the graphics stack. So at this point, we haven't focused on the graphics stack, but that is going to be addressed this year. So last year we were basically putting together the core layers before the application framework. This year, I think the focus is going to be more about the application framework, the UI frameworks, and the SDK for the user. So the release by the end of this year is what we expect OEMs and ODMs to show more interest in, because it will be a lot more full-fledged. I think there was a comment from Augustine. We should have a common session, free desktop SDK and Oniro to learn from each other. Absolutely. So one thing I'd like to clarify about Oniro, we are not trying to reinvent the wheel here. We are trying to use what we feel are the best components in the open source software ecosystem. So whether it's a build system, Yocto, kernel, Linux, and on the MCU side, maybe Zephyr and something else that comes along the way. Application frameworks yet to be decided, but some mix of JavaScript as well as things that people, I mean, for example, Qt could also be an interesting choice if the license works out. and then the UI on top of that. So at this point, we've used LVGL as a software project. And the goal is to actually contribute everything from Oniro, any changes that we make in Oniro, back to these upstreams. So we will be engaging with Yocto as part of the and in OE core, for example, inside Yocto, we have contributors to the Linux kernel, to Zephyr upstreams. We've just recently ported LVGL 8. We've upgraded the version of LVGL in Zephyr from LVGL 7 to LVGL 8. So the idea is to constantly push these changes back upstream and only keep the hardening layer that we need, the minimal hardening layer set of policies that is usually not acceptable upstream, keep those in the Oniro layers. So there's another comment, I believe, by Augustine. Can you mention a little bit what has been unstreamed? Oh, I guess that you mean upstreamed. I think I just addressed that comment. So if there is anything else you'd like to for me to touch upon, Augustine, please feel free to write in chat. All right. Are there any other questions? So I believe we have another 15 minutes or so. So I don't mind hanging around if people have questions. But if people would rather do something else, that's fine as well. Thank you very much for attending, asking questions. I'm available on email and chat. Please feel free to reach out any of the other team members that are attending FOSDEM about specific parts of Oniro that you might be interested in. We have a fairly large contingent this time.